This is checkpoint 1.15. They want us to find the area inside the cardioid defined by the equation r is equal to 1 minus cosine theta. So let's see if we can imagine this cardioid. R is equal to 1 minus cosine theta. It looks like when theta is equal to 0, cosine of 0 is 1. We start at the origin. When theta is equal to pi, cosine is 0, so that'll be positive 1. So it'll grow as we go over here. When cosine is pi, it'll be negative 1. 1 minus negative 1 is 2. It'll reach the bottom over here, and then it'll come back and make the cardioid. This is our graph. They want to find the area inside this cardioid. And the formula for the area is going to be given by some angle from 0, or in this case 0 to 2 pi. We went all the way to 2 pi to get this. But the generic formula for the area is going to be 1/2 times the radial distance r squared, and r is the function f of theta, and then times the angle d theta. And so we cut up these angles and then add them all up, and it becomes this integral. So this is our formula. So it looks like we're going to simply put that in. Let's take the 1/2 out for now, and let's put the integral from 0 to 2 pi of the function 1 minus cosine theta squared d theta. Okay, now we're going to FOIL it out. I guess is the best thing to do, because I don't see any other ways to do this. Or you can just punch it in and get the results. But let's see if we can take this as far as we can, doing things by hand and trying to remember how all our integrating techniques. FOIL will give us 1 minus the same sign, twice the product plus the last one squared. Okay, so the last one squared is going to give us a cosine squared, which will require a double angle formula. So I don't know if we remember that, but the whole idea in breaking this up is that we can now split this up to 3 integrals. The first one is 1 times d theta. The second one will have a 2 on the outside, cosine theta, and then the last one, the 1/2, is all the way out here, so let's not worry about that. And this is where we get the double angle formula. Okay, now let's see. This is going to be theta, and evaluated from 0 to 2 pi is going to be 2 pi. The cosine, if you imagine, let's do this off to the side here. If you imagine the cosine function that looks like that, from 0 to 2 pi, and we're looking for the area under the curve, it looks like they'll have the same positive area as negative area, so this is actually going to amount to 0. So now we're, oops, I forgot my d theta here. So anyways, that's 0. Now we're left with this last one, which again is going to require a half angle formula. So let's just run through and say we have the half angle formula figured out, and the contribution that this is going to make is going to be 1/2 theta plus 1/4 sine 2 theta. And this is going to be evaluated from 0 to 2 pi. Okay. All right. Multiplying this through, we're going to get pi over here, and then plus a 1/2. Let's put 2 pi in Let's evaluate this. By the way, when you put 0 into theta, sine of 0 is 0, so there's no contributions for 0. So we just need to worry about what happens when we put 2 pi in there. So 2 pi in there, we're going to get pi. Pi times 2 pi is pi. And sine of 2 pi, 4 pi, sine of 4 pi is 0, it looks like. Because we'll have 2 times 2 pi, that's 4 pi, sine of 4 pi is 0. So there's that. And we just have pi plus 1/2 pi, 3 pi over 2. And that should be your area. Okay, I hope that helps.